In exercise 83, find b such that the line y equals b divides the region bounded by the graphs of the two equations into two regions of equal area. So we have the graph of y equals 9 minus x squared, something like that. It's a parabola with a y-intercept at 9 and x-intercept at -3 and +3. The region we are defining is bounded by this parabola and the graph of y equals 0, so this line here. Now that region, we need to divide it into two regions of equal area using a horizontal line, y equals b. And the goal in this exercise is to determine how high this line needs to be to satisfy the condition that this region here is equal to that region here. So, one way of doing it would be to set up the integral to set up the integrals to find the area of this and set it up equal to the area of that. It's not the best idea, but let's make a little effort and write it down. What I'm going to do if I want to find the area of the top part is I need to know where I'm starting and when I'm stopping. So from negative a to a. Everything is symmetrical here. So I would be integrating from negative a to a of the top function minus the bottom function, top minus bottom, dx. And this would be equal to the area bounded by all these curves. And that is the integral from -3 to -a. I'm talking about this little region here of 9 minus x squared, top minus bottom, which is 0, plus the area of this rectangle. So we have two options for the area of this rectangle. Either we use integral, top minus bottom, or we just acknowledge the fact that it's a rectangle, so the area is base times height. The base is 2a times the height, which is b, so plus 2ab, plus the integral of this little slice here, which let's write it as an integral, but you probably are thinking of something else. It's the integral from a to 3 of 9 minus x squared dx. If you were thinking that this area is equal to that one, so we could have just multiplied this by 2, that's a great idea. Okay, so that's one way of doing it. By the way, we haven't figured out what the value of a is, and we would need to calculate that before moving on. But there's another way to do all this, and it is to actually first calculate the area of the whole region and then say, well, this needs to be half of it. Okay, so we could recycle this part of my expression, of my equality here, and just say equals half of the total. That's another possibility, and it looks like it's going to be a little faster. So, first of all, I'm going to look for the total area that I have, everything bounded by the two functions. It's the integral from -3 to 3 of 9 minus x squared dx. So the integral is 9x minus 1/3 x cubed, evaluated between -3 and 3. If I plug this in, I get 27 minus 27 over 3, so 27 minus 9 minus -27, and now this is becoming minus 9, so plus 9. So that's 18 plus 18, 36. So the whole area is 36, and therefore we want the top part here to be equal to 18. The integral from negative a to a of 9 minus x squared minus b dx, I just copied from here, should be equal to 18. Before we move on, we're going to do something that we could have done from the beginning, and that is to recognize the fact that these two parts are symmetrical about the y-axis, so that instead of always integrating from negative 3 to 3 or from negative a to a, we can just integrate from 0 to 3, 0 to a, and it's just going to be half again of what we have. What I mean is, if this area is 18, it's 9 and 9. So we can rewrite this again and just say we're going to integrate from 0 to a, and I need that to be equal to 9. It's not necessary. If you go with this, it's perfect. If you go with what we had up here, it's perfect. It just might be a little longer. Okay, at this point, it's going to be valuable to find what a is. A is the intersection of, is the x value of the intersection of these two lines. So if we want to find the intersection, we set up 9 minus x squared equals b. And if we solve for x, we find, so x squared equals 9 minus b, x equals plus or minus the square root of 9 minus b. What is this plus or minus? It's actually a and minus a. So the one we want is the positive value, so it's plus square root. A equals the positive square root of 9 minus b. Okay, so I'm going to write this. I'm integrating from 0 to 9 minus b of 9 minus x squared minus b dx equals to 9. So all I've done here is just to substitute a. Now I know that a is equal to the square root of 9 minus b. I'm glad because I'm looking for b, so I'm happy if I can get rid of other variables that I don't know, or other unknowns that I would need to find. So let's do that. The integral of x of 9 is 9x. The integral of x squared is 1/3 x cubed. The integral of b is negative bx. And we're going from 0 to the square root of 9 minus b, and this is equal to 9. So 9 times the square root of 9 minus b minus 1/3 of the square root of 9 minus b cubed, so 3 over 2, minus b times the square root of 9 minus b equals 9. What can we do from here? We can factorize the square root of 9 minus b. Square root of 9 minus b times, I have 9 such parts, minus 1 over 3 times 9 minus b. If I extract 1/2 from the exponent, I still have 1 left. And finally here minus b equals 9. 9 minus b to the power of 1/2. This is all technical stuff. This is part of why this exercise is difficult, because there's so much to do. Here, notice how we have 9 minus b minus 1/3 9 minus b. I'm just going to rewrite it. 9 minus b minus 1/3 9 minus b. So in effect, we have 1 9 minus b minus 1/3 9 minus b. So we have 2/3 of 9 minus b. So doing all this juggling allows us now to put 9 minus b to the power of 1/2 times 9 minus b together again. I'm not sure this is the best method. Whatever, as long as you don't make mistakes, it's fine to not minimize every single step. We're going to multiply by 3 and divide by 2, so I get 27 over 2. If I take the square of this and then the cube root, for the denominator, the square of 2 is 4, and so I'm going to have the cube root of 4. For the numerator, I'm going to actually do it the other way around. I'm going to first take the cube root and then square it. The cube root of 27 is 3, and the square of 3 is 9. So in the end, I get b equals 9 minus 9 over the cube root of 4. Quite a work in order to get to this answer. If we want to know exactly what b is, or if we not exactly, this is the exact answer. If we want an approximate answer just to get a feel, it's equal to 3.330. So it's much lower than, it's much lower than half, of course. The parabola is like that. It's wider at the bottom, so you don't need to go very high. Y equals 3.330 in order for this area to be equal to that area. Let's move on. Now we have a bridge. Concrete sections for a new building have the dimensions in meters and shape shown in the figure here. Find the area of the face of the section superimposed on the rectangular coordinate system. Find the volume of concrete in one of the sections by multiplying the area in part A by 2 meters, and knowing that 1 cubic meter of concrete weighs 5,000 pounds, find the weight of the section. I said it was a bridge, but it's not a bridge. Okay, so let's focus on A, find the area. So we're finding the area of the front here. We're ignoring the depth for the moment, just the area of this. Alright, so we're looking for the area of this whole thing, but in fact we're going to use the same trick as in the previous exercise. We can find the area of this and multiply by 2. So we're going to integrate from 0 and all the way to the end. The very end is at 5.5, but the graph of 1/3 square root of 5 minus x hits the x-axis here at 5. So, and the top is at 1. So what happens is we need to split this into 2 parts because top minus bottom changes. Here it's 1 minus this curve. Here it's different, it's 1 minus 0. It's not the same bottom anymore. That's easy to find. The area here is base times height, so 1/2 times 1, it's 1/2. For this one, on the other hand, we have to integrate from 0 to 5 of top minus bottom. 1 minus 1/3 square root of 5 minus x. Okay, let's see what this gives us. 0, 5, 1 minus, I'm going to write it like this. It's easier if I want to integrate. And now the integral of 1 is x. Here I'm going to make a guess. This is my guess. And now I need to think backwards. What happens if I take the derivative of that here? 3 over 2 is going to come in front, which I don't want. So in order to fix that, I'm going to do, let's say that this is 2 over 9, because if I multiply by 3 over 2, it's going to give me 6 over 18, which is exactly 1/3. But if I differentiate this whole thing, I'm also going to have a multiplication by -1 because of the inside derivative. So again, I don't want that, so I need to change this sign. and I'm integrating from 0 to 5. So let's see what this gives us. 5 plus 0 minus 0 plus 2 over 9 times 5 to the power of 3 over 2. Okay. So do I have this value somewhere? Yes, I do. I've calculated it earlier. It's 2.51548. So what it means is that the area is 2 plus 2.51548 plus 1/2. So area equals 3.01548. And so the entire area of this section here is twice that. I'm going to multiply by 2. It's equal to 6.03096. So that's the answer for question A. Question B and C are much shorter. In question B, they tell us to actually find the volume. So we need to multiply by 2 because the depth is 2. That's very easy. The volume is 12.0619 cubic meters. This was square meters because it was an area. Cubic meters because it's a volume. And finally, to find the weight, we need to multiply by 5,000. So the weight is 5,000 times the volume, and it yields 60,309.600 pounds. One thing we can mention here is the importance of keeping a lot of decimals, more than I kept here, because you want your final answer to be correct to 3 decimals. If you only keep 3 decimals here, when you multiply by 5,000, you won't have any decimals. So make sure you keep enough. In this exercise, we have a cubic function y equals 2x minus 3x cubed, and it is sliced, if we want, by a line y equals c. And now you have the blue area here and the red area there, and we need to find how high y equals c is in order for the two regions in blue and red to have the same area. So what we will do is we're going to try to find this area and set it up equal to that one. So clearly we're going to really need to know what these points are. And so before we move further, let's give them names. Let's call this A and call this B. So this is the point AC and this is the point BC. They both have the same height. In order to find A and B, which will be the bounds of my integrals, I have to set up 2x minus 3x cubed equals c. That's a problem because I don't know how to solve cubic equations, and to be honest with you, that's why this exercise is really hard, because you're stuck right from the beginning and you don't know what to do, you don't know how to move forward. Maybe we can factorize, but what does factorizing help here? Nothing at all. When it's equal to 0, then you can say, well, x equals 0 or this equals 0. But when it's equal to a number, you can't make any progress. You can't say either x equals c or 2 minus 3x squared equals c. That's a classic mistake that we want to avoid. So we are really stuck right from the beginning. But actually, it's not impossible to solve by just moving forwards with 0, a, and b as such. So what we need to set up is the integral from 0 to a of c, so top minus bottom, c minus 2x minus 3x cubed dx has to be equal to the integral from a to b of 2x minus 3x cubed minus c dx. We have an abundance of unknowns here. We have c, we have a, we have b. It doesn't look like this is going to work very well, but in fact it does. If we integrate this, we get cx minus x squared minus minus, so this becomes plus 3 over 4 x plus 3 over 4 x power 4. That we evaluate between 0 and a. And that has to be equal to the integral of this from a to b, so it's x squared minus 3 over 4x 4 minus cx from a to b. So let's see what happens. We have, if we now use the fundamental theorem of calculus, substituting a and 0, we get ca minus a squared plus 3 over 4a power 4 minus 0, 0, 0, so minus 0. On the other side, b squared minus 3 over 4b power 4 minus cb minus, and we're going to subtract a squared minus 3 over 4a power 4 minus ca. So let's get rid of these parentheses here. ca minus a squared plus 3 over 4a power 4 equals b squared minus 3 over 4b power 4 minus cb minus a squared plus 3 over 4a4 plus ca. And this is where we suddenly see that we are making great progress. ca cancels out, minus a squared cancels out, 3/4 a power 4 cancels out, and we get 0 equals b squared minus 3 over 4b power 4 minus cb. From here, we may want to start by factorizing b, but in fact there's something even better that we can do at this point in this highly difficult exercise, and that is to substitute the value of c. We know that c is the output when you plug in b in the cubic function. So if we put b here, 2b minus 3b cubed, we get c. That means c is 2b minus 3b cubed. So I can use that down here. B squared minus 3 over 4b power 4 minus 2b minus 3b cubed times b. Let's see where this leads us. Minus 2b squared plus 3b power 4. Okay, so maybe now it's a good time to factorize b squared. B squared, I have 1 minus 3/4 b squared minus 2 plus 3b squared. B squared, 1 minus 2 is of course negative 1, and here I have negative 3/4 b squared plus 3b squared, so this comes together as 12 minus 3 plus 9 over 4 b squared. So I'm getting close to the answer. Now this can be split. It's a different case than before. This time it's either b squared equals 0 or this equals 0. B equals 0 is not, it doesn't make sense in this exercise. It must be some kind of extraneous solution. Having b all the way here, what does it mean? It's kind of a degenerate case where we have no regions. So the other option is this here, and if I move the 1 to the other side, 9 over 4b squared equals 1, b squared equals 4 over 9, and b equals 2 over 3. It's plus or minus 2 over 3, but again, we can see that b is a positive value, so we don't have to think about b being equal to negative 2 over 3. Okay, so we found b equals 2 over 3. What is then c? Well, we know from the beginning that c is the image of b, it's the output of b, 2b minus 3b cubed. So it's 2 times 2/3 minus 3 times b cubed is 8 over 27. So that's 4 over 3. This is 8 over 9. And therefore, altogether, we find 12 over 9 minus 8 over 9, 4 over 9. This is the final answer, c equals 4 over 9. Just before I stop, there was actually another way to set up this exercise which would have worked just as well. It's kind of a clever idea. Instead of setting this equals to that and flipping what is top minus bottom, another idea which basically leads to the same calculations after a few lines is just to say that the integral from 0 to b of 2x minus 3x cubed minus c dx equals 0. If we go from 0 to b, from 0 all the way to b, we'll have one of these is going to yield a positive value and one of these is going to yield a negative value. Actually, this one is going to be a positive number, this one is going to be a negative number, but they will even out, and the sum of those two will be 0 when they are equal. So that's, you can start with this equation. It doesn't even involve the value of a. You just go all the way from 0 to b, and the integral has to be 0. That's another way of doing it. If you try that, which is a good exercise, you'll see that soon enough you get the same equation as I had.